Welcome. Welcome to NTNU Evening. We are now in our 16th season. The consequences of the climate change have become frighteningly clear to us. NTNU has many researchers working to find sustainable solutions and how we can succeed in the demanding changes that are needed. Tonight, we are investigating hydropower with the title How to Develop Hydropower While Ensuring Biodiversity. What are the challenges? How to create sustainable water services in the future? What does this mean? Tor Håkon Bakken leads the Sustainable Hydropower Project. What will be the new role of hydropower? Status, challenges and opportunities. Tor Håkon is a professor in the Department of Civil and Environmental Engineering. Please, the stage is yours.
Thank you, Randi, and thank you, Odin. Thank you for coming here. I will try to give you the big picture about hydropower, where we are today, in what direction hydropower can go, and what are the challenges and opportunities related to hydropower. So in some way define the context for the work in SUShydro. These graphs here, or these bars here, they show the annual production of power from various low-carbon sources. And it might come as a surprise to some, because you see that among the low-carbon sources, hydropower is by far the dominating. So these are data from year 2020, but it's not that big changes up to today. And you can see that wind power and solar power are much lower. So actually hydropower stands for almost twice the power production as wind and solar together. And I think this statement from Dr. Veit Birol, the director of International Energy Agency, is quite precise. So he says that hydropower is sort of the forgotten giant of renewable technologies. And in Norway, I guess all of you maybe know that hydropower has been a dominating source of electricity. So up till maybe 20 years back, almost 100% of electricity came from hydropower. And it's been a gradually increasing share of wind power the last 20 years. But hydropower is big, and that's also the picture globally. So there are many countries worldwide that have a big share of hydropower in their electricity production. It can also maybe be a little forgotten because it's been not so much new development in Norway and Europe the last 50 years or so. So it's just been the power production that's been operating and working and producing power for many years without any or so many new projects. Another element I would like to address here is we know that the energy system must change. We need to phase out oil, gas and coal. We need a fully renewable system. And we need bigger shares of some of these intermittent renewable sources like wind power and solar power. And the challenge with some of these power sources is that they produce when the wind is blowing and sun is shining. So we need some sort of technology to fill in these periods where the demand is high and the power production from some of these intermittent sources is very low. And the pie chart here shows how is that solved today, which technologies are able to fill in, provide flexibility in periods that when this is needed. So you can see that almost 1/3 of this is covered by hydropower today, and a small third on gas and also on coal, and there are some other technologies that fill in. But it's important to keep in mind now that coal, gas and oil should go out. So hydropower needs to play a more important role, and also the need for flexibility will expand because we will have bigger shares of solar and wind in the system. And the photo to the right here, that sort of illustrate what are the key elements in the energy system, and that is the reservoirs. So they are very important. Reservoirs can store water, they can store energy. So these are very important. We have many reservoirs in Norway, and there are reservoirs, of course, outside Norway too. And they will be more important in order to phase in and enable solar and wind in the energy system. So keeping in mind that these reservoirs are important, I will come a little later back to what they are used for. But this is also something that the International Energy Agency has produced in their net zero emission report. So how shall we be able to achieve the goal of having net zero emissions by year 2050? So you can see that this graph here that increase a lot. These are wind and solar power. So they are expected to have a much bigger share in the energy system and produce much more electricity. But at the same time, hydropower is also increasing. So this dark blue graph here that shows the expected growth, increased production of electricity from hydropower. So compared to year 2010, it's expected almost a doubling of also the hydropower production. So it can be that hydropower will change its role a bit. It will be more important for providing flexibility, but also sort of the baseload production will probably increase. These are two graphs showing what reservoirs today are used to. And this is maybe a little surprising for some of Norwegians, because all the big reservoirs in Norway, they are used for hydropower as the main purpose. Well, that is what they have been developed for. So the graph to the left here that shows reservoirs and what they're used for, reservoirs that are defined as single purpose, having only one purpose, one reason they are developed. So this is the majority of the reservoirs in the database from ICOL, and you can maybe be surprised. Pretend like you are a little surprised. So about 50% of these reservoirs globally are used for irrigation, and irrigation only. And only 20% are used for hydropower. So it's quite a low share of the reservoirs globally are used for hydropower. In Norway it's 100%, but outside Norway in the big world, then hydropower is not the most common use. This graph to the right here, lower right, that show sort of the same, that is the multi-purpose, and what are these reservoirs that have more than one function, what are they used for. And we can also see here that hydropower is not one of several functions in all these multi-purpose reservoirs. Only 40% of these reservoirs are used for hydropower, together with some other type of use. So what do these tell? I think it tells that the reservoirs have been used within one specific sector. This is big infrastructure, important infrastructure in terms of drinking water supply, irrigation, power production, and so on. And maybe it's possible to use this reservoir better if you take into account other sectors, and also open up for use of this reservoir for also power production, if that is not the case already, or if it can also be used to secure drinking water supply or for flood control, if hydropower is the main use. So I think it calls for a kind of a intersectoral cooperation. I also included climate change, and we do not do dedicated research on climate change in SUS Hydro project. But I think also keeping this August in mind, it's difficult to do research on the long-term use of reservoirs without keeping climate change in mind. Climate change has happened, and it will be accelerated in the future. It will definitely affect the hydropower production. We already see today that the existing hydropower plants, they produce more power than they were planned to do when they were built in the 50s, 60s in Norway. We also see that the reservoirs can dampen flood. That's a very important feature of hydropower. We saw it to some extent this summer, but reservoirs were quite filled with water already. We were so lucky in the spring, and we were so happy in the spring. We thought, well, the reservoirs are quite filled, and then that will guarantee low power price in the winter. But when the flood comes, then we would hope that it would be more space to dampen the floods. But the reservoir need maybe more to be managed together for electricity production, also for flood dampening, and maybe in the future also to reduce the risk for droughts. We have seen some summers that's been very dry. We see that it can be problems for supply of water for farming, for irrigation. Maybe we need to introduce irrigation to a large extent here to supply water for drinking water supply in Norway, and maybe also use reservoirs to mitigate ecological stress that we see sometimes we've seen in Europe, for instance. I've been talking a lot of positive things about hydropower and reservoirs now, but everything is of course not fine. Sort of the nature movement in Norway was formed related to the sort of resistance against hydropower. We have many rivers in Norway that have almost no flow at all. We have many reservoirs with big fluctuations that cause problem for the long-term recruitment of populations. And we also see hydro peaking, this rapid variation in flow due to backing up, for instance, solar and wind. So we need to do a job in order to make hydropower greener, because there are hundreds or thousands of kilometers that are quite dramatically affected by hydropower regulations. I return a little now back to sort of the background for these PhDs and in Hydro and in all these 11 projects. So what is really sustainable? And it's not so easy to say what is sustainable, but the European Commission has done a work on this. They have published a report called the Taxonomy Report that defines criteria for how should the different actors define criteria for different sectors, how should their services provided be in order to qualify for being sustainable. And also there are clear criteria for hydropower in this report. And the aim of the report is to provide a basis to allocate funding into more sustainable projects. So when it comes to hydropower, there are some criteria here. I think hydropower basically, at least in Norway, do well with respect to social performance, economical performance. When it comes to environment, it's a bit more of a discussion. But if you divide the pillar of environment into what is clean in terms of climate change emissions, so I think we have quite a good performance on that on Norwegian hydropower. The emissions from Norwegian hydropower is very low, typically 3 to 4 grams CO2 equivalent per kilowatt hour. So I would say that Norwegian hydropower is clean, but the other aspect is if it is green. And the criteria stated by this taxonomy report is that it should do no significant harm. And I shouldn't conclude here if Norwegian hydropower do significant harm or not, but you saw the previous slide that there are many dry rivers. So it's a question there, and it's a debate in the hydropower sector today. So then I try to sum up what are we working on in Hydro project. We work on hydropower as an enabler for the integration of solar and wind. We do research on that because I think hydropower reservoirs are a key feature in the future energy system. I think hydropower needs to improve its ecological performance given these dry rivers, big variations in water level in reservoirs. And I think also hydropower must prove that it also gives other types of services than electricity production. It must prove for the society that it has other benefits as well. And I think we need to keep in mind that climate change happens. Even though we don't have any dedicated research on that, we need to keep it in mind because we do long-term research. Thank you.
Thank you, Tor Håkon. We proceed and we'll welcome Viviane Aubin from Quebec in Canada. She took her bachelor's in mechanical engineering and a master's in energy Engineering from Polytechnique, Montreal. Before starting her PhD at NTNU, she worked at Hydro-Quebec, the equivalent of Statkraft and Statnett in Norway. Quebec has a lot of hydropower and a bit of wind power, just like Norway. In her PhD work, she is investigating how to use hydropower best in the low-carbon energy systems, while considering the related environmental issues. Please, Viviane, floor is yours.
Thank you, Randy, for this nice introduction, and welcome everyone to our edition of NTNU Kveld. This baby doesn't know yet, but a lot will be expected from her in the upcoming years. First, she'll be expected to be able to walk. That's usually manageable. But then, she'll be expected to get good grades at school, to live on her own, to get a job, and possibly to raise children. Yes, when we grow up, expectations from society towards us rise. And interestingly enough, this does not apply only to human beings. Hydropower is also confronted to rising expectations from society. And my PhD is trying to figure out how it can manage to meet those expectations. This is what hydropower looked in its infancy. It's cute, right? At that time, it was quite simple. Just put a wheel in the water and that's it. What we expected from hydropower was to provide power. But then society evolved and we started using electricity, and then we started building sophisticated infrastructure to bring water to fancy wheels that produce electricity when they turn and that we call turbines. So with a bit more work, we managed to have hydropower provide us with electric power. And it seemed fine for a while, but a few decades ago, we started caring about how much hydropower can affect its surroundings, like creating dry rivers that Turakon talked about. Indeed, once we have hydropower in a water system, the water flow starts depending on the power production. So at times of low power demand, this can mean low water flows. So in order to mitigate those impacts, we started to operate hydropower plants according to some rules that we call environmental constraints. Those environmental constraints can be minimum water flows to be respected, and it can also be restrictions on how fast the power production changes and hence the water flow. So it's a bit more challenging to operate hydropower plants with environmental constraints, but it's manageable. And then, recently, the energy transition started. So that means more wind power, more solar power, and that's a very good thing, because those technologies are key to tackling climate change. However, the problem with wind and solar power is that they don't always produce. The wind doesn't always blow and the sun doesn't always shine. And at those moments, we need a reliable source of power to rely on. As we can control how much water we use from its reservoirs, hydropower can compensate for the fluctuations in wind and solar output. However, if hydropower takes that balancing role, that can lead to more variations in the water flows in the rivers, which were precisely what we were trying to mitigate with the environmental constraints. So it's starting to become a bit challenging, and that's not all. Because do you know what we currently use to compensate for the fluctuations in wind and solar output? Fossil fuel power plants, which are precisely what we're trying to get rid of with the energy transition. So not only will hydropower have to take a balancing role for quickly rising shares of wind and solar power, but it will also get less help for doing so. Seems a lot, don't you think? So how can we manage? How can hydropower contribute to the energy transition while preserving local ecosystems? Do we have to choose between the biodiversity crisis and the climate change crisis? Those were the questions I was asking myself when I was working in the hydropower industry. And those are the questions I'm hoping to help answer with my PhD. With my PhD, I use mathematical modeling. Mathematical models are great, I tell you. Indeed, with them, we can carry a bunch of different tests without having any other impact than using a computer. So, for example, we can test various ways to use hydropower in order to understand how to use it best. So, in my PhD, I have a mathematical model of the Nordic power system. It's basically a bunch of equations that describe how the whole power system works and all the constraints that it has to fulfill. So, for example, we have to have enough power to supply demand at all times. And we also have all the environmental constraints that apply to hydropower. So what I do in my PhD is that I create different scenarios that try to represent the future in which hydropower will have to evolve. So in those scenarios, I put more and more wind and solar power, and I also add more and more environmental constraints to hydropower. Those constraints, as I said, can be various things. So it can be minimum water flows, ramping restrictions on how fast we can change the power production. It can also be restriction on water levels in reservoirs. And I can also apply those environmental constraints to different power plants. For example, those that are located in environments that are especially critical to preserve. So once I've built my scenarios, I put them in the model and give them to the computer for it to solve the whole problem. And what does that mean, solve the problem? Basically, I want the computer to tell me how do we operate the whole power system in those scenarios. And then my role is to analyze the results. So there are various things I can look at. For example, I can look at the power production, so how much power is produced at each plant, when, how much power is produced by hydropower specifically. I can also look at the water management. So how does the water look in the reservoirs, in the rivers? Does it make sense given the environmental constraints? And a thing that is important to look at is also the electricity prices. Because the more pressure we put on the power system, the more likely higher prices become. And we don't want to recreate an energy crisis like the one we experienced last year. So yes, that's what I do with my PhD. I'm trying to simulate the future to understand how hydropower will be able to manage all these different constraints. I'm trying to understand what will be hydropower's role in the power system with lots of wind and solar power, while it has to fulfill a lot of environmental constraints. And I can tell you already, it won't be easy. But we don't have a choice. Our world is facing great challenges. Expectations are rising towards human beings as well as towards hydropower. And in order to meet those expectations, we won't have a choice but to behave like real grown-ups. Thank you.
Thank you, Viviane. Really interesting. Lennart Schönfelder is the next to come and teach us. To produce electricity from hydropower, large water reservoirs are needed. The operation of these must also take into account other uses such as water supply, irrigation and flood control, as well as hydrological risk and optimization. Water supply and demand vary with seasons, with economic, ecological and societal factors. Lennart's research assesses multi-purpose use of reservoirs in order to find a system-wide and socio-economic maximum. And how is he doing that? Please, Lennart.
Yeah, thank you, Randi, and thanks everybody for coming tonight. After these really good examples by Håkon and Vivian, I can really focus on the fun bit, because they took away so much of it. That's great. So even it's a really technical title, I can really just show off my summer holiday pics with you tonight. That's my plan. But before we do that, I want to really quickly introduce how a single-purpose reservoir would look like for a hydropower installation. In this case, we have only a reservoir that works like the battery in this system, and the water from this reservoir goes through a turbine to generate electricity, and then from there it goes back in its natural water course. That can be a river, another lake, or in the Norwegian case, often it's a fjord. But now to the promised vacation pictures. So this is Molo and another friends floating down the Elva in Trondheim this summer. And they're enjoying themselves. And what looks like just a normal pic, it's really a good example of a multi-purpose use. Because what they're floating on currently, that's water that was used, that came from Selbesjøen, and then was used for hydropower production in Nedre Leierfossen, maybe you know the plant just upstream. And now they're floating on it. So in this case, these two uses of recreational activity on the downstream reach and the electricity production, they are synergetic and they do not compete with each other. To another picture of my holidays this summer, this is the Bolarque reservoir just east of Madrid. This reservoir, it functions as a hydropower system. There's two plants down here. At the same time, a lot of the water goes through a large canal system, the Tajo Segura Canal, and goes to a dry region of Murcia to supply water for agriculture and for potable water, also for drinking water. And in addition, there's also people using beaches at the other side of the lake, and there's boating on that lake. So it's a multi-purpose reservoir, again, but this time we have trade-offs between the different uses. Because the water that goes into hydropower production, it cannot be used at the same time for potable water in Murcia. So these two uses are competing. In addition, agricultural use for water is often happening in the summer when the plants grow and it's dry. But at the same time, you would like to have this water inside the reservoir so you can use your kayak or your boat on it. So now we have a trade-off between these uses, and they are competing with each other. That's the last holiday pic, I promise. This is Mulu again. This time we're back in Norway on the Trekanten hike, and you see in the background that's Gråsjøen. It's part of the Trollheimen power system. It's a quite essential power system for our region. And in comparison to what it would look like if we used the battery up in the summer and we emptied the reservoir, this is what the lake looked like. So if you focus on the lake here, it's a very different experience of this hike, right? And we have another example of a competing use between hydropower and recreational activities, but also ecology. So what do we do about that? And that's where I kick in with my PhD. I'm also modeling. I think Vivian did a great job of explaining how the model works, so I can really focus on my setup. What I didn't discuss yet is how do we actually charge our hydro battery, the reservoir. This is covered by water flowing into it, and I do deal with that in a hydrological model. So then we have the inflow clear. Now I added some more of the multi-purposes. We have flood control that was mentioned earlier. We have ecology happening at different spatial scales. So ecology is important not only inside the reservoir, but also in the bypass reach that was shown dry before today, and also on the downstream reach. So even though it's one of the purposes, it can compete within itself in a way. And then, of course, we have the power production as an output. So all these uses, they have different benefits for society, but it's not straightforward to make them comparable and to transform them into a mathematical equation because they give different outputs. For an example, agricultural water will have food production. Recreational activity will be well-being or joy of the users. And the hydropower production, of course, gives electrical power. So to quantify those and make them comparable in a mathematical system, it's often just transferred into profit, which of course in food production or electricity it's a bit easier. With joy, it's not easy to translate joy into money. Yeah, so that's part of the challenges that I'm working with. And of course, what I'm trying to do is then optimize all these different uses at the same time to generate an optimum for all the stakeholders. Then we're already at almost the end. The main takeaways of my talk today are that reservoir hydropower, in comparison with other energy resources, have a unique role in that they have additional services that they have to fulfill. These services can compete or they can synergize together. And to optimize it, it's important to identify all the stakeholders and quantify the uses. And of course, my plan is to find the optimal equitable solution that is sustainable and benefits all the stakeholders. Yeah, that's it for me.
Thank you, Lennart. Hanne Bjørnås Krogsti is the next to enter this stage. Humans are increasingly altering the natural environment on a global scale, affecting existing patterns of environmental variation. Are species and ecosystems able to adapt to all these changes? Hanne's work is to understand how the environmental variation caused by hydropower, such as changes in water levels of lakes, affects freshwater communities. Hanne has completed her master's degree in natural resources management at NTNU and is PhD candidate at the Department of Natural History in the NTNU University Museum. Please, Hanne.
Thank you, Randi, and hello everyone. It's nice to see so many people here. As we heard from Lennart, ecology is also important. And now in my talk, I want to give you a kind of a deep dive into the more biology aspects of hydropower. And I want to talk about the highs and the lows of life in a hydropower reservoir. And with my work, I want to help increase biodiversity knowledge so that we can develop hydropower in a more sustainable direction. So first, if I asked you to imagine an animal living in freshwater, I would guess many would picture a fish. And that makes sense. We eat them, we like to go fishing, maybe we even have them as pets. But while there are maybe 1 or 2 fish species in most lakes in Norway, there's a whole community of animals that we step right over if we ever go for a swim or even go fishing. And that's the benthic invertebrates that we find in the shore zone of lakes. And while we know quite a bit about fish, we know much less about these invertebrate communities. But what we do know is that they play an important role in the lake ecosystems. So these invertebrates are insect larvae, snails, and other organisms that play many important roles. They might be breaking down leaf litter and other material that ends up in the lake. They help filter the water. And many are also important food sources for fish, for instance. And our brown trout, which many might know, often prefer to feed on these invertebrates in the shore zone rather than in the open waters of the lake. And we also have several studies that show that if we impact this shore zone, it can have cascading effects throughout the lake ecosystem. So if we care about lake biodiversity, we should also care about these small animals. And here you just see a sample from such a community and some of the diversity that you can find. So it's a lot of different creatures that are crawling around. But when we regulate hydropower, or lakes for hydropower production, we get the ability to decrease or increase water levels, depending on how much electricity we want to produce. But this also means that we are making big changes to the environment of these organisms. And if they want to survive, they have to be able to adapt or to follow the water as it changes. Imagine, for instance, that your house suddenly disappears, or that your local grocery store is shut down. I think such events would be quite stressful for most of us, And this is in a way what these organisms also experience when we regulate for hydropower. And typically in Norway, when we regulate, we get a lot of fluctuations throughout the year compared to natural lakes. And we also typically see a big drawdown in wintertime. And here you can see what it looks like to the left after such a drawdown. These are 2 lakes that we are studying here in Trøndelag. So you see how different they are after the drawdown and when they fill up again. It looks like 2 different lakes almost. So different communities might have different abilities to adapt to environmental changes. And this is what I'm interested in with my PhD. So imagine a town or a city which lives close to a river. This might be more prepared for a flooding. Maybe such a town has emergency housing and food and water in place, while a town further from the river might not be as well prepared. And what I want to know is there also differences between the invertebrate communities and how they're able to handle environmental changes? So maybe there are certain community types, maybe those that have a lot of species, or maybe there are communities in certain regions or areas that are better or worse at handling these changes. And for one of my projects, I want to look at this by looking at how these communities change throughout the season. So we go to 6 different lakes in Trøndelag, and we take samples throughout the spring and summer of the communities. And this can help us to then compare how the communities change over time, and possibly if we can see any differences between the communities in regulated lakes compared to unregulated lakes. And what I hope in the future is that maybe this knowledge can help us to find maybe new or better mitigation measures, for instance, for taking care of biodiversity while we also produce hydropower. And another project I'm working on is more broad scale. So I want to see if we can find any patterns of impact. If we look at a lot of different invertebrate communities across the country. So I'm starting now my work with Norway, but maybe I can also work on several countries in the future. So what I want to see is if I find data that's been collected by different institutions, maybe often for lake-specific cases, can we gather this together and analyze it for trends, which can help us to identify, for instance, if there are certain regions, maybe lake types or lakes in certain altitudes that are better or worse at adapting. And maybe this knowledge can help us in the future when we're planning new hydropower sites to know where we should or shouldn't put them to have the lowest impact on nature. Or maybe it can also help us identify areas which require stronger protection. So in the end, I just wanted to kind of draw a bit how my work is connected to sustainability. So what does these small bugs have to do with sustainability? We know that we are facing some big challenges. We need to face both the nature and the climate crisis, but we also know that these two are connected. And we know that from nature, we get a lot of services and benefits that we rely on for our societies to function as they do today. We also know that climate change will negatively impact both nature and us. But if we work towards maintaining biodiversity, we can stand a better chance at minimizing these negative effects, because we know that if we have well-functioning ecosystems high in biodiversity, they are more robust when it comes to handling the changes that will come with climate change. And that again will increase our likelihood that we can still provide, or we can still get, the benefits like clean water and food from such ecosystems. So for hydropower, I think reducing the impact it has on nature is one of the big challenges that we have to take seriously if we want hydropower to be a sustainable source of clean energy. And as I've tried to show in my talk, what that could actually look like is providing these small organisms with food and shelter that they need to survive. Thank you for listening.
Thank you, Hanne. Kristianne Dalsbotten Solvåg is a biologist with a master's from NTNU, where she focused her study on how environmental variation affects the movement patterns of brown trout. In her doctoral research, she has replaced fish with insects. So now she is diving into the life cycle of insects living in hydropower reservoirs to investigate how they are affected by water level regulations. Kristianne is a researcher at the Department of Biology. Please take the stage.
Thank you so much, Randi, for the introduction, and it's so nice to see so many people here. As said, my name is Kristianne, and today I'm going to talk to you guys about the life cycle of aquatic insects and how we can affect them if we regulate lakes for hydropower purposes. But first, I want to talk to you guys about environmental variation. The most obvious example of environmental variation for us humans is, of course, the weather. It changes through the years and varies with the seasons, but of course we know that it also varies on a much shorter time scale. For example, a week, or we're in Trondheim, we can say it varies within a day. And this short-term variation is often much more unpredictable and feels much more random than the seasonal patterns. So this daily variation, it affects our daily lives. It can, for example, affect what we choose to put on in the morning or how we choose to get to work, and probably a lot of other decisions as well. But it doesn't just affect us. Most organisms experience some form of environmental variation, and that includes the aquatic insects that live in lakes and hydropower reservoirs. And just like us, they also have to navigate their lives making decisions based on this environmental variation. And note that they live much shorter than us, so while we choose what to wear, they have to choose when to get kids, which is something I'm really glad that we don't have to make decisions about based on the upcoming weather. And yeah, but no matter the decision we have to make, we have some benefits the insects don't. We have calendars that can say something about where we are in the season, what kind of seasonal variation we can expect. We have weather forecasts that they're not always accurate, but they're pretty helpful on a daily basis. Over the years, we're also getting some experience, which I have symbolized here with the all-weathers jacket that you usually acquire if you have been in Trondheim for a year. And last but not least, we are also so fortunate to have overlapping generations, which means we can also benefit from the experience of others, such as our parents, and get some good advice from them. Insects, they don't have this. But still, they are able to make some pretty good decisions. And how do they do that? So that's what I, as a biologist, is wondering. And yeah, it's also what I'm thinking about when I'm out collecting them in the lakes. What they can rely on instead is environmental cues that varies with the season. That can mean day length, it can mean temperature, and for aquatic insects, it can also mean water level. And together, these kind of make up a calendar, which the insects then can use to time or decide what to do with their life or important life decisions. And when we regulate a lake for hydropower purposes, we are changing this water level. We are changing how it varies. For compared to a natural lake, a regulated lake will often have a higher amplitude, so there's a larger difference between the maximum and the minimum water level. We often experience more very short-term variation, and this is especially true if a reservoir is used to balance out the wind and solar power. And last but not least, sometimes we just mess up the entire pattern of variation, such as if we have a winter drawdown. And this means we are messing up the calendars of insects. And what are the effects of messing up their calendars? That's what I'm wondering in my research. Some species may be able to tolerate it well. Some species might get their life cycles drastically changed, and some species may not be able to tolerate it at all and may disappear from a lake. And I'm interested in finding out what traits of that species, what characterizes a species that is vulnerable to these changes, and which aspects of the water level regulation causes the most disturbance to insects. To do this, I am out in the field collecting insects throughout the spring and summer, and to find out what happens in their life cycle here in Trondheim or in Trøndelag, and does it differ between natural lakes and regulated lakes. And I will then follow up on the data I get from that with a model that simulates the decision-making of insects, and I can do that to simulate what happens in the lakes we are actually looking at. But since it's a computer model, I can also make it so it simulates different kinds of scenarios of water level regulation. And finding out how insects react or make their decisions based on environmental variations such as water level fluctuations, it's kind of a piece in a larger puzzle. It helps us just understand the mechanisms behind insects' life decision, which is useful for water level, how it's affected by water level regulation, but also any other pressure that changes the environment or the environmental variation insects experiences. It can help us understand how hydropower affects a range of species, which, as Hanne said, is really important if we want to maintain biodiversity and ecosystem functioning. And it is also a step towards understanding the ecological effects of these new scenarios that we are expecting due to hydropower more and more having the role of compensating for wind and solar. And just putting it all together and to sum up, water level regulation can kind of mess up the insects' calendars, which then can impact their life cycle. And my work is trying to create a tool that can predict how these insects are affected by water level regulations in both current and future scenarios. That was what I had to say. Thank you all so much for listening.
Thank you, Christiane. Sif de Visser is from Netherlands, and where she studied environmental science. She is now researching how to develop methods and models for life cycle analysis related to various challenges in hydropower production. She calculates how land use, water consumption, and greenhouse gas emissions collectively affect nature and the ecosystem. This will result in a global screening to identify potential hotspots where efforts are needed. This knowledge is used for more environmentally friendly electricity production. Sif is doing her PhD at the Department of Energy and Process Engineering. Please, Sif, the stage is yours.
Okay. So today I will talk about sustainable hydropower and mostly about where and how. In the Stone Age, decision-making was not so easy. We just had rocks, but no paper, no scissors. So they had to be very inventive. Today, we like to make more informed decisions. So that's why we use the models that Vivian and Leonard talked about today. But we have different types of models. And my PhD is about making models for the environmental dimension. And the overall goal of the environmental models is to find a balance between generating enough electricity but also minimizing the harm to the environment. Well, this is a very traditional approach to look at emissions. So in this perspective, hydropower scores pretty good. It's one of the winners. But when we look at land use, we see a shift, and then the hydropower performance is only mediocre. And nuclear or wind power performs much better. And why do we look at land use? Why is this important? Well, first of all, if we transform natural areas and exploit these, we will lose species. But also, if we cut down trees, we won't have the trees taking up CO2. So we're indirectly also contributing to climate change. So this shows how important it is to have everything in your model. We can't say anything about environmental friendly if we just look at emissions. One important concept in environmental sciences is the planetary boundaries concept. This picture shows clearly how many different crises we're dealing with. It's not just climate change, it's also biodiversity loss or ocean acidification. And they managed to quantify some limits to how much of this crisis we can deal with. So if we're in the green zone, we're still safe. But when we extend our impact, we don't know. We will find ourselves in unknown territory. So it's important not to go there. If we zoom in, we see we already surpassed the boundaries for both climate change and biodiversity loss. And I'm showing this picture because I think it's really important to realize that we surpassed the biodiversity boundary by a lot already. So this, How do we translate this to hydropower though? Because it's a very global model. It doesn't tell us how much hydropower we should generate. But since we already surpassed so many boundaries, it actually makes more sense to look at how can we minimize the impact of hydropower. So that's why we use the tool life cycle assessment. And our work looks a bit like accountancy. So what we do, we look at inputs and outputs and we compare them. But instead of money, we look at the material we need, the transport we need, and energy, of course. And the outputs could be the product we produce. It can be emissions or waste. But it wouldn't be life cycle assessment if we just did this for one process. So we need to follow the whole life cycle of a hydropower plant. So we look at the extraction of raw materials, then we move on to the construction of the hydropower facility. Then we look at the impacts during the operation of the hydropower plant and the dismantling of the dam, of course. So where would you expect the most impact? Well, the studies that are out there right now, they will point at the first one because we use so much concrete, so the impacts are very large. But what they didn't look at is the biodiversity impacts. So what would happen if we take all of those in account? I will show you now what we need to model to cover the biodiversity impact in LCA for hydropower. First of all, we need to consider fragmentation. A salmon species, he grows up in a river and then goes back to he goes to the sea to feed, to grow, and then he needs to go back to the river to lay eggs and move on. But it becomes very difficult with a barrier like a dam or a road in between. Then we have a lot of species living at the bottom of the river, but the bottom of the river is changing because the sediments get trapped behind the dams. Then we have the temperature changes. Well, we learned from Christiane that there's a lot of cues that species respond to, and this is one of them. So typically in Norway, in the winter we have a slightly warmer bottom layer of the water, but because of the turbine, this water comes up, it becomes the upper layer, so this affects the species a lot. And then the reservoirs, they also emit greenhouse gases because there's organic material at the bottom and it decays. So this will have a global effect on all the biodiversity, not just at the hydropower facility. And when we build a dam and we create a reservoir, we're flooding a lot of other species like grasses and trees, and well, they will be lost for sure. And then we have evaporation. From the reservoir, a lot of water will disappear, and it will not be usable for other species downstream. And last but not least, referring back to Christiane and Hanne's presentation, we've seen what flow regulation does to our insects, and it's not good. So if we add up all these models together, we get a unit, and it's the potentially disappeared fraction of species. What can we do with this? We can make a lot of relative comparisons. So here, for example, the use case could be, what is the worst environmental impact? Is it one large hydropower, or is it better to have 3 smaller hydropower which generate the same electricity amount? But we can also look at better locations to place our hydropower facilities. Some rivers may be already highly fragmented, so if we add more hydropower, this will be even worse. Or we know, for example, in the tropics, usually reservoir emissions are a lot higher than in Norway. So it's a lot of things to take into consideration where you place your hydropower. And then if we take a bigger look, even outside our project, ideally we have these models for all the different type of energy sources. So if we do this for wind power, or solar, or nuclear, or anything, we can do even better strategic site selections for the locations for energy system. But all in all, choices will always remain difficult. It's a lot of balancing between pros and cons. And then we didn't even add in the economic factors, social sciences, or politics. And that's why I'm really happy to have the whole SAS Hydro team, so we can try to navigate towards a common language between all the disciplines, because we work with interviews, words, and then we have all these models which produce numbers. So how do we compare this, and how will this affect our choices in the field of sustainable hydropower? Thank you.
Thank you, Sif. And now we have listened to all our presenters, and I will ask all of you to come to the stage, and the audience to prepare for some questions, comments, reflections, whatever you have, please. Yeah, there is one of our students. Here's a guy with a microphone. So if you raise your hand, he will get your hand, and you will have a microphone. And please say your name and give your question. All and everything is understood. There is no. Here's a guy, please.
Hello. Thank you for a superb night and fantastic presentations. My name is Håkon Sundt. I'm very interested in hydropower and all aspects of it. I have kind of a comment or a question that might not be so easy to answer, but might be discussed. And I see in several of your presentations you kind of showcase different aspects of hydropower, and my question is, how do you plan to kind of compare these different aspects? For example, if a politician was to make a decision on how to use his reservoir, how would he base his decision on? Lennart, you mentioned like money, but how do you translate human joy, recreation to money? It's easy for the other parts, but Is there any idea how to compare all these different elements, or is the discussion on that? It's a kind of a politician's question or a social question of sorts.
Thank you. I think if you want, and now it's very good if you can just, we don't expect any of you to really give the fastest answer. We don't have that. But to reflect and to comment, that will be very fruitful. Please, Lennart.
Yes. Yeah, thanks for the question. I think it's a really good one, and it's one we're currently working on. When you remember Vivian's presentation, we often talked about environmental restrictions. So currently, this kind of benefits for ecology or for recreational use, they are often enforced by just restricting the operational use. And I know of very few examples where hydropower operators actually use it as a target, as an ecological target, or a recreational target. It's often just used as a restriction. And that's something we work on to implement in our models, these kind of targets. And then we don't have a really good answer yet, I guess, for assessing the value of it and making it comparable. I mean, there is concepts like willingness to pay, for example, that you can use. And one more thing that I wanted to say. No, maybe I'll leave the rest for...
but you can come back.
Yes.
Sif, would you like to comment or reflect, other of you? Yeah, please, Vivian.
I can add something maybe. I think it's, basically your question is the goal of our whole project, trying to get some hints of an answer to your question. And it's a very difficult one. But I think we're also trying to find if there's any synergies, like some environmental constraints, for example, in my case, that we can implement that can help a lot the local environment without affecting too much the hydropower production. So if there's, like, we're talking about a lot about trade-offs, but maybe there are some synergies. So that's a hope that we have, and also to have our biologists trying to understand also what kind of operating modes in hydropower affect most the ecosystems. I think it's very valuable information to take better political decisions.
I also have a comment.
Please.
Well, one approach could be that if you are owner of a hydropower facility, that you might have to consider if you are following, for instance, the EU taxonomy. So if how you operate will be in thread with having a sustainable management or sustainable hydropower, according to, for instance, the EU taxonomy. We also know that there are whole fields with developing, for instance, environmental accounting, so setting a price on nature. But I think this is still a big and complicated field to understand how everything could be translated into money, for instance.
Maybe even canoe paddling and leisure activities and life quality could be translated into some money standards. Would it help for the politician, or what do you think about that?
Yes, definitely. Yeah, I mean, some of the users definitely have a lobby, and I mean, some lobbies are louder than others. If you think about ecology, that they don't have anybody to, nobody's talking for the insects normally. And that's part of the problem too. Yeah, that we don't know yet how to evaluate them against each other, because some are really loud and present, and some are not.
Please, to Håkan.
Maybe I can just comment a little, and it, of course, trying to find the monetary value, that is one approach, and it's been tried a bit, and but maybe it's not been completely successful. But I think Håkon raises an important issue that is sort of in the core of the project, that you ask where you need to widen up what are these assets used for. They will be more important in the future, and Lennart touches that by introducing other types of interest. How can we include that in optimization, and the impact on the biological research on the biological impact in the reservoir, that we need also to know more about what happens with the biology using the reservoirs in a specific way, and of course the work of Vivian, and I guess it's in sense of the life cycle analysis to try to include at least all the environmental impacts into one tool, so you can make developing different sites comparable. So I think you ask for what sort of the essence of SysHydro project is.
Good. Do we have more hands? Yeah, please. Here are two on this side.
Hi, yeah, thanks for great presentations. I have two questions actually. One for Hanne. You said that we need to see how the hydropower and the changing levels affect the housing basically of the invertebrates. And I was just wondering if that also translates to increasing the water levels or if there's other strategies then to help the invertebrates. That's one question.
Yeah, that's a good question. I think using the house is a bit of a simplification, of course. These animals can usually move around. They don't build, some of them do, but most of them maybe don't build a permanent house. But maybe a part of it is understanding just how these species and how these communities act. Maybe we can find that like certain times of year are critical, or that certain times we need to have good enough water levels, but maybe other times it doesn't matter as much. For instance, if we think about when they lay their eggs, what time of year, yeah. Maybe that helps a little bit, yeah.
Yeah, thanks. And then there's, for Sif, I was wondering, in your research, I think in LCA you often use like libraries or so of data, right? And then I was wondering if you find the data you need or if you have a lot of issues like building your own proxies or things like that.
Well, there is hydropower in the databases. So you can, for climate change, you can find out how much CO2 equivalent there is in the whole lifetime. But there are only a few models that are developed by my supervisor that translate this impact into biodiversity. So yeah, you can just compare one pie of all these environmental challenges right now. Yeah.
Yeah, that's what I thought with the biodiversity, that's probably not so explored.
No.
Yeah.
I mean, it's very hard to, I mean, Hanne is already upscaling a lot of patterns, but to upscale it to LCA, it's even a lot more simplifications and assumptions that you need to make.
Yeah. Thank you. Great work.
Thank you. There was another hand there. Yeah.
Thank you very much for very inspiring presentations. My name is Helge Brattebø. I'm a professor of industrial ecology and directing NTNU Sustainability. I have a question to Viviane first, because your project and the modeling approach that you have should ideally, also be based on inputs from the other guys, and environmental understanding, environmental knowledge, and so on. To what extent is that possible when you're working with a kind of a macro model on a very large system? It's kind of a top-down. And then I have a question to all of you afterwards, or you might take it if you want to answer. Many of you do modeling, and you combine it with case studies. So you go out with your magnifying glass, diving into the river or the reservoir and so on to understand the mechanisms. And I would expect that there are huge variations depending on where you are, where your study or where your case study is. Do you by purpose want to study case studies in different countries? And is the methodology approach more or less the same? Or how do you reflect upon the variability of what you find in order to feed into some kind of generic model? Thank you.
Okay, I will start with the first question. So I think, yes, ideally, all these guys would tell me exactly what environmental constraints we would need at every hydropower plant, but it's not that easy. But so I think actually we can learn a lot of actual bilateral exchanges, so that I can also give them estimations of what hydropower operations will look like in a higher renewable future, so that they can look at possibly like in their own models how this would affect the local environment, and then possibly identify some things that are more critical, and then I could test those I could try to attenuate those impacts, and I think we can, just by having this exchange, we can learn a lot. And for the case studies,
I can maybe chip in with a really practical example on how we do interdisciplinary work, and also regarding your test cases about internationality and nationality. So currently, for example, Vivian and I have a common master student that we left it sort of open to him which test case to pick, but we pushed it a little bit towards a test case in Malaysia that Shawa is also, she's in the audience today, she's also one of the SAS Hydro PhD students, that Shawa is working on. And that's one way of starting a collaboration, because we realized the last year that it's not so easy to just start an interdisciplinary collaboration when you're not really sure what the other person is working on or what's interesting to them. And I think to focus on common test cases is really a good way to go.
Good. Are there more of you that want to comment on that last question? Yeah, Tor?
Maybe about selection of test cases. And ideally, we would try to find these case studies that will enlighten the research question we have at hand. But I can also say in the real world, when you do research, there are also practical consideration with respect to selection of test cases. So when the biologists go out and measure, and maybe you go, I don't know, every week or every month, you cannot select a test case in Germany. So, and you also, about the availability of data, we cannot measure everything from scratch, and sometimes you need data that has been collected for many years. So based on a more practical situation, we also select case studies.
Mm. Combination of reality and vision. Yeah. Yes, there are more hands. Good.
Hi, my name is Ole Andreas Alsos, and I have a question. I work at NTNU, but I have a question about biology. Are there any positive effects of hydropower dams? Regarding biology, there are of course flooding and electricity. That's great, but any species that love hydropower dams?
I can try to answer some of it, maybe. I think it depends on your perspective. I think we have seen some cases where you can kind of, with the hydropower installations, you can modify the flow in a river, for instance, that in a way that can promote maybe some fish species. I don't remember if it's salmon or trout, I think, so that they can increase in numbers, maybe in that river. But that's not something we do everywhere. And then you have to ask, do we really want to modify all our rivers so they are suitable for one species? We have to also remember the rest of the ecosystem. Do you have any other good examples?
No, it's just, that in general, some species will thrive in a very disturbed environment, but often because there's no competition from a lot of other species. So some will thrive when most don't. So, yeah.
If I can try to add a little, and maybe it's a little provocative because I see people from the Environment Agency in the audience here, but depends on to the better. So how do you define a more fundamental way of looking upon the ecosystem that all types of human intervention is negative? So in such a situation, you cannot say it could be to the better. But if you do management of salmon, for instance, if the goal for the environment or the kind of a metric for a good environment is the salmon population, I think we can find cases in Trøndelag, in Orkla, maybe in Nidelva, that has been beneficial for the salmon production. For instance, because of the winter flow. In many rivers, the winter flow is higher in regulated rivers because they produce electricity during the winter time and more water. And if winter is the limiting factor because of low flow and ice maybe, then it can be beneficial to have a regulation because you have more water during the winter time. So I guess it depends a little on how you define for the better. So a more fundamental kind of way of looking upon it, it will never be better if you do some human intervention. But if you want to sort of stimulate a specific population, you can do things that are to the better.
Yes, yeah, there is a hand here.
Yeah, hello. First, I would just like to congratulate NTNU for another very excellent event regarding sustainability and hydropower. For those of you which haven't watched the Arendalsuka, where they also had the same event, just go and look into it. It was very nice. So you were very good at also for popularization of your topics. I have a challenge to you. The Nature Panel are saying that we need transformative change to innovate both to handle the climate and the nature crisis. I think we can only go like 5 years back, and even hydropower industry in Norway, they were mainly talking about we are climate friendly, we are climate friendly. They had a narrative about this. And we saw from what Tor Håkon presented that, okay, there are some side effects and they need to go into this. Renewable energy, they withdraw their guidelines regarding how to report on the taxonomy. But still, most of the large-scale hydropower producers have reported on this. And like Statkraft, 97% sustainable according to the taxonomy. For those of you which are going into the model and finding new scenarios, if you just look into those which have modeled the electricity prices, they didn't foresee these extreme high prices we have had even in Norway in the last years. So I would just challenge you, when you are doing work with the scenarios, let's say that we really need to do transformative change and take like nature, biodiversity, kayaking and such to take it much more seriously in a way. You need to also challenge that one. What is really needed to really meet these targets? And in a way be really think new and be innovative of what we really needs to do in a way. So not to limit, not look into the mirror, but look into the future. And let's say we really need to do something totally different. We need, like, if you get back a feedback from a reviewer, we need major revisions of how we are doing things also for the hydropower industry. So maybe you have some reflection on that.
It sounds, thank you for...
I was Johan Rake, by the way.
What? Yeah, I didn't get the last time. But maybe Tor Håkon will start that.
Maybe you shouldn't challenge the smartest first.
Yeah, yeah. I thought that was a very huge question, but yeah.
It was a very good comment, as always, from Johan Rake. So it's not so easy to see, but maybe we can look to see if there are some rooms of opportunities here. And when we talk about new hydropower, it's not so much new hydropower that's developed in Norway no, but there are good ideas for changing the existing hydropower fleet. And one of the ideas is to develop more possibilities to produce power in short periods. Effect in Norwegian. More effect, less terawatt hours. So, and that means we have the possibility, and the business idea is fantastic, I think, because then we will produce more power in periods with high price. And we can import power and pump up in the reservoirs in periods with very low price or even negative price. So we can sort of store the water up in the reservoirs in periods with and let them leave the water there until the price goes up. And Europe needs electricity from reservoirs. That sounds like making the systems regulators even more difficult for the environment and ecology and so on. But there are some possibilities there. If you talk about the reservoir, it can mean, and there has been studies on this, that if we use the reservoirs for pumping in period, we can reduce the drawdown period a little. Maybe it doesn't go so low during the late winter as it is traditionally, before the snow melt starts. So maybe there are some synergies there. Actually, if we use the right plants, not all, but these ones that are technically and environmental fit for that, for producing more power in periods. And then maybe we can improve the conditions in the lake to at least reduce the fluctuations over season, but maybe it will be bigger fluctuations on a short term, on daily, weekly basis. So there are some possibilities there, so we can also fulfill the economical expectations for hydropower and also maybe improve the ecological conditions some places.
But you were challenging us for really thinking totally new. Young people are the ones that do that. Hanne, will you comment?
I just had a comment. I think that a part of this conversation around energy, we also need to consider how much energy we really need and maybe challenge that a bit in society. And I know that there was a report, I think this year, from the Norwegian Energy Commission, which was called More of Everything Faster, mer av alt raskere. And I've heard that some of the feedback or the reactions to this report from many different agencies has been that maybe we can't take all of these future scenarios just for granted. We have to also challenge them and see how much we can reduce the energy that we need, because all the energy that we can save means less impact on nature. Yeah, that was just a thought I had.
I want to give a little comment myself. In Israel and other countries in those latitudes, they have developed for decades systems of reusing water several times and have a circular hydropower. In this country, we haven't even thought of the possibility that we could lack the water. I don't know. Is this something that anyone in Norway are thinking of? Or is that to save water and to reuse and to save all the constructions and nature?
I'm willing to blame myself. But I think they talk about two different things, about securing the supply of drinking water. That is one thing. These are very small volumes compared to what we use for hydropower. And in the case of Israel and other countries, it's cheaper to recycle the water than finding new sources that are clean. So I think it's about cost, and they also do desalination. So, but in Norway we have basically so much water for drinking water supply, so that is not a needed solution. When it comes to hydropower production, and you mentioned this cycled or closed kind of systems, and that's kind of a pump storage plant. So you can imagine a closed system with a reservoir on a low level and one at a high level, and then you make it completely closed. So that is kind of pumping. So in periods with high demand, high price, you release water and produce electricity. And then in periods with a lot of sun, a lot of solar power, a lot of wind power, you pump it back in a closed system. So you benefit from the price difference, and it's not only about profit, it's also about the need to have a stable energy system. So there are some cases of this, and these coupled reservoirs that I mentioned, that is sort of the same thing, I think. But I think the hydropower sector, they have many plans on their desk now. They can do it, but they wait for the right political signals how to realize this. And of course, they're waiting what happens offshore with offshore wind and so on.
Yeah. There is a new question.
Thank you, and thank you very much for a really nice presentation from all of you. A bit different from what I've seen from NTNU usually. My name is Katrine Tegnander, and I'm actually working in the oil and gas industry. I'm not sure if I dare to say that here. But anyway, with a power plant and with the renewables, we should ramp down. And we need help to do so within the oil and gas. And I was just wondering, with your work, and we're thinking about the long traditions that we do have in Norway with power plants, how do you think your work would help to optimize the power plants that we have today in Norway? How can your work help us to go faster toward the green change?
Yeah, I think, if I may answer.
Yeah, please, Leonard.
I think how we can contribute is that every one of us, in a different way, challenges current law frameworks and current operational patterns, and we try to find ways to make the power system the hydropower system more flexible. And I think that's part of the deal, because we can only, I mean, there's going to be more demand in the future, we all know that. And there's a big debate about electrifying the norsk sokkel, which would also increase the demand. And we can, at least in Norway, not do that by hydropower, and we are aware of we need more volatile renewable energy for that. And I think all of us, to an extent, work with enabling hydropower to be more flexible towards these technologies. Yeah, so that's maybe part of the answer.
And maybe I will add that we're trying also to quantify the impacts, but also the benefits of hydropower, so that if hydropower has to change the way it operates, that we can focus on what really matters. And so maybe leave some hydropower plants in an operating way that is more conventional, and use the flexibility of other hydropower plants, which can have more benefits and can maybe accept to sacrifice certain rivers and to use other ones, or to try and preserve other ones. So that could be an idea.
Other people would like to give comment? No? Okay. I see hardly anything. It's dark. Here's one more.
Okay, my name is Jan Petter Rubransen. I'm also with the Norwegian Environment Agency. This is not much a question, but more like a piece of information and reflection, maybe. It's so that together with the Directorate of Water Resources and Energy, NVE, we are now in the process developing a huge program under the wings of NORAD, and it's called Energy for the Development. And it's of course about renewable energy. And for example, in Nepal, which is one of the 6 countries which has been selected, there's about water and water hydropower. And the NTNU has been in forefront for years and decades on hydropower. So in Nepal. And coming here tonight, it's very nice to learn that no, it's not only hydropower, it's also hydropower and biodiversity. For certain that the new program will be developed with the basis and with connections to the Kunming-Montreal Agreement on the new biodiversity framework. So hydropower and biodiversity will certainly be linked even more than even before. So it's very, very nice to learn about that, and I hope that really not only not only Norway, but also that we can, in development assistance, we can contribute. And of course, NTNU has been and will also forward be in forefront. Thank you.
Thank you. Somebody wants to comment? Yeah.
I can just comment, and NTNU is very much eager to contribute to such work, and I know there are no ideas to try to develop and maybe position the university more in being the leading renewable university, and maybe we should add biodiversity university in the world. So it's been a long tradition for having hydropower development master students. We have this master course on hydropower development that we would like to sort of upscale also to include other types of renewable sources, and we should also, of course, be aware of all the sustainability challenges.
Yeah, that sounds good. Yeah, there's one with on side wall. You will be the next.
I got the microphone first, I think.
Yeah, please. Yeah.
I don't have a question. I just have a comment. I really enjoyed your presentations, and I think all of you have made a really good choice when you have decided to do a PhD on such an important topic. And we can see from all the questions or comments here that there are really high expectations. And I just want to relax that expectation a little bit. I mean, NTNU has studied hydropower technology and how to expand hydropower for, I think, 100 years, you don't have to solve all the problems in your 4 years or 3 years. So you already made a good decision for focus on this topic, and it will be valuable. But remember that you also have to do some detailed, high-quality science, not only solve all the political questions and all the big problems in the world. So just keep up the good work.
Hopefully we can do both.
Please, next.
Hi, how are you? I am representing the Narrating Sustainability project, which sort of is in a very different field. And I wanted to also thank you for your presentations and also for a lot of the comments about, the type of modeling, the kind of, data you integrate into your predictions. And my question is, maybe in contrast to some of the final comment here, it's what about citizen science? What are people in this, in your research? Because actually the UN Development Goals are quite specific in broadening the understanding of sustainability, not only to focus on technological, economic sustainability, or even climate change, but very centrally place environmental injustice and questions of indigenous rights and land use at the center of them. So I wonder, we didn't hear much about citizen science and people, so I wonder how people, not just the folks on the top feature in your research.
Come, thank you, Hannah.
Yeah. We're waiting for the social scientists.
Yeah.
Shawa is also in the project, and we would like her to come for another evening and tell about her project, which is really something touching what you are mentioning now. But yeah, please.
I should also use the opportunity to introduce Hossein, that's doing economical research related to common use or shared use of hydropower reservoirs. So he is the 7th PhD student in this project.
Mm. Yeah, you mentioned the citizen science method. Is that something you are thinking of, or could you reflect on in the big project?
I can maybe just say a comment. Yeah. I know that citizen science is playing a bigger role now in biology and research on biodiversity. But it's a type of data that also has its own unique challenges. So for now, we're not, as a biologist, we're not using that type of data. But I know that it could suddenly be of use if someone else has the time to work on it, I think. I know of several other people who have been working more with citizen science that maybe we are in this project.
And maybe also another comment. When I say environmental constraints that apply to hydropower, it can also be community constraints, so constraints that try to mitigate the impact of hydropower on surrounding communities as well. So at least on my side, it's pretty much the same type of modeling.
Yeah, there are even 2 more hands, one sitting close to the wall and one in the front.
When listening to you, I really feel good, because it seems like you have a project with all aspects you presented as students obviously are important, and filling in to the total picture. So I would really, even if I agree, certainly as a PhD student, it's so important to focus on solid research, on the knowledge development in your field, and you will defend in your discipline. However, having a discussion among yourself, I mean, this project is super nicely constructed to stimulate that. A question towards the end, and again, thank you very much for the presentation and your answering to the questions. Who do you think would be the main users of knowledge that you develop?
who do you want to use? Who would really need this knowledge to make it into the politics or action?
At least for my part, there are a lot of hydropower licenses that are renewed these years and that will be renewed in the future. So if my work can inform the process on where these licenses should add more environmental constraints and where it would be relevant and not too damaging for the whole power system, I think it would be a great achievement.
Yeah, Lennart?
I can maybe add that I think this is most realistic, that I hope my research is going to be used internationally, because we know in Norway we have a lot of good tools for optimization, and we have a lot of knowledge about the systems, whereas in other countries, especially developing countries where there's a lot of potential for hydropower left, they could make good use of decision support system. For example, Brazil could be one of these countries where you have a lot of potential left and they don't have so much knowledge, and there the biodiversity crisis is much more heavy too. Norway is quite sparse in terms of biodiversity. If you crank up the temperature a little bit, you have many more fish in your reservoir and in your rivers. So to partly answer your question, I would hope that it can be used internationally, be it by government or producers or environmental groups. Yeah.
Maybe I should add one element that is maybe a little ignored in the scientific society, because it's tendency that you would prefer your publication read by other scientists. And that is of course good, and that gives credit as a scientist. But I think it's important an event like this, that what they know, what they work on is shown to the general audience. And I think it's also very important that to try to get in contact and have a dialogue with the sector that they develop research for. And of course the products are these papers they produce, and it will hopefully, I'm sure, it will be very good, but in the end, maybe more important is what stays in the brain. So I hope you will stay useful in industry, in authorities, in Norway or outside Norway too, but I think much about Norway now, but I hope your knowledge is adopted in industry or other research institutions. So this is the start of your scientific career. So I hope so. So if you don't stay, I will chop off your head.
I think we have one more question, and that might be the last one.
Hello.
Please.
My name is Martha, and I didn't know anything about hydropower before I came here. So thank you for making me an expert. I was just wondering, because you're talking a lot about the sea or the freshwater animals, but does land animals also have an effect on this? And is this something you study or know anything about? You want to take it?
I can just say quickly, now we are just focusing on what's living in the water, but we have a lot of different animals that are connected to or related to freshwater, like a lot of bird species need the water or feed there. We also know that we have several mammals, like beavers, who also use these habitats, and when we regulate it, it can also affect them. But I think it's a bit out of what we are able to look at, but yeah, for sure, it's not only the things actually living in the water that are affected.
Yeah, and also aquatic insects is actually like they have one part of their life cycle in the water and the other on land. So it's also kind of like a link between the freshwater and terrestrial system.
Okay. Then I will thank you so much, the PhD students that have done a big effort. They have been in a process of coaching since May, June, and working with their story, with their research, and they are very early in the 4 years work. So it's not so easy to have a lot of spectacular results to tell about. But I think you've done very much about methodology for how to find something, how to solve, what methods can be used to find out. That's also very interesting, and you have really given us, agree with the woman here, I didn't know so much about hydropower either before I started with this, but we learned a lot. And thank you to all and everyone in the audience. We never know, does it come 1, 5, or 50, or even more people. And I'm very happy to see that even this specific project, which is 47 PhDs in NTNU, is a big strategic effort to gain new interdisciplinary research in these coming 4 years. So we will present more. This is first round of first group, and there will be tomorrow 4 new people telling us about circular city. And what is circular city? It's how can we just not demolishing all the buildings we may make and throw it away and take new resources out of nature for building new buildings? How can we reuse the materials in existing buildings to have it reused in the cities? So that will be another very interesting research program, which is also in this sustainable research that NTNU has put a lot of energy into. So I will give a good applaud for the work you have done and wish you good luck with the rest. And there are several more people in the audience that are also part of the group, and we will listen to you later. So thank you for coming, and all the best rest of this evening.